Hello, my name is Marcela Souza. I'm a postdoctoral researcher at Ghent University, and with this audio, I would like to guide you through one of our newest publications entitled Microalgal Cultivation on Grass Juice as a Novel Process for a Green Biorefinery. So, green biorefinery is a process that aims at converting green biomass, such as alfalfa, clover, and grass, into several products for the bioeconomy, such as feed, fuels, chemicals, and materials. This usually starts with a pressing step that separates the biomass into a fiber fraction and a juice fraction. This juice fraction is the focus of our work, and it's usually quite high in proteins. So you can directly precipitate these proteins from the juice and have a product that can feed monogastric animals such as pigs and also humans. However, it has been shown in past studies that when the juice has a low nitrogen content and therefore a low protein content, this process is not profitable. So we are proposing to use microalgae cultivation as an additional step in a green biorefinery for processing exactly this low nitrogen juice. So the microalgae can actually uptake this low concentration of nitrogen and increase the and up concentrate this nitrogen into microalgae biomass, which is rich in proteins. And the interesting part is that you're not only going to produce proteins, but also pigments, lipids, antioxidants, and possibly sugars, depending on the microalgae you choose. So you actually, by introducing microalgae cultivation into the green biorefinery process, you actually also expands the amount and types of products that you can get from this green biorefinery. So how did we do this? So first, we produced a green juice out of grass, and we noticed that it was actually quite dark and wouldn't allow for light penetration. And light penetration is very important for microalgae cultivation because they're photosynthetic organisms. So they do need light to produce organic carbon. But we did notice that this was mostly because there was a lot of suspended solids in the green juice. So we just proposed a first sedimentation step, just allowing it to naturally settle. And especially after dilution, this sedimentation step was very efficient. And actually, we were able to get a quite transparent liquid out of it, which was still rich in nutrients. But we did notice that this liquid was still very acidic, so the pH was around 4. And for the green microalgae that we wanted to cultivate, which was chlorella, the pH is usually should be around 7. So we proposed a pH adjustment to 7 and used several dilutions, so 5%, 10%, and 15%, to see how the microalgae would grow in this grass juice. And interestingly enough, the microalgae actually grew much better in the green juice, especially at 5 and 10% concentration, in comparison to the mineral medium that is usually used for microalgae growth. So this means that not only the green juice can provide all the nutrients necessary for microalgae cultivation, but they were actually providing something else that was helping the algae to grow. And this might have been organic carbon. So the microalgae might have been able to do what we call a mixotrophic cultivation mode, which uses both photosynthesis and organic carbon, and then this usually increases productivity. We did notice there was some bacteria growing with the algae, so we actually tried to do a second run with a pH adjustment to 8 to inhibit bacterial growth, and this was actually quite good. The microalgae still grew very well, and we did reduce the bacteria loading. However, this is a point of attention in our study. So we should improve the processing of the green juice and the protocol for algae cultivation to reduce the microbial load in the final product. Nevertheless, we were able to produce a biomass with 41% protein content, which is actually comparable to soy meal, and with no contaminants, and just the microbial load for yeast and enterobacteria was a little bit off, so we should continue researching on a better way to produce this and reduce this microbial load. But yeah, overall, we were able to use a low nitrogen source to produce microalgae in a green biorefinery. So I hope you find this interesting. Please do read the full paper. Don't hesitate to get in contact with any of the authors if you do want to know more about our research. Thank you.